Hi NET aspirants, it's that preparation. It's back with AUB. We are moving along Conic-Section. Now we are about to start circle from AB initio. We are about to start circle AB initio. First, we have given general equation of circle, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. We have to prove that center is given by minus g minus f and radius of this equation is given by square root g square plus f square minus c. Mostly students can apply these two concepts, minus g minus f and radius. They plug in some values, they are in a position to find center and radius. But we are about to dig deeper down to get to the reality how this center and radius come from this equation. Let me write this equation here: x square plus y square plus 2 times g times x plus 2fy plus c is equal to 0. Tip to inspect the equation of circle: x square y square, they both have same coefficients along with the symbol. They both have same coefficients along with symbol. It is the tiny aid for you to recognize, to classify the equation of the circle. Now we are asked to find its center and radius. We have to convert this equation in this standard form, that is x minus a whole square plus y minus b whole square is equal to r square, where a and b are the coordinates of center and r is our radius. We have to convert this equation, we have to transform this equation in this type, in that standard form. So for that we have to make perfect square formula for x as well as y. I have written together the terms involving x like terms, then the terms having y and the constant on the right hand side. To make this perfect square, it's x square plus 2 times x, there is g, x square 2 times x times g, there must be g square, there must be g square in order to make it a perfect square. For this, y square plus 2 times y times f, y square plus 2fy, there must be f square is equal to negative c. We have added g square and f square on the left as well as on the right in order to balance this mathematical equation. G square has been added on both sides as well as f square has been added on both sides. Now look at this, it is a perfect square formula for x plus g whole square. What about this? It will be y plus f whole square. Here, if I write positive terms first, g square plus f square minus c. We have almost transformed this equation into this standard form. Just manage square here, overall square, and here minus symbol. So they can be written as x negative g whole square. We are in a position to compare this. This is our value of a. And this can be written as y negative times negative f whole square. And here I can write this is y g square f square minus c whole square. Now compare with this equation, that is our standard equation. We have x minus a whole square, y minus b whole square is equal to r square. Compare, we have value of a is minus g, value of b is minus f, and without square r is equal to g square plus f square minus c. So our center AB is equal to negative g negative f, and radius is mentioned, and we are directed to do so. We are directed to do so. So we have met our assignment requirement. Center is minus g minus f and radius is g square plus f square minus c. That is the science or chemistry behind from where comes or occurs this center as well as radius. From where comes or occurs this center and radius. Now you have good idea, fair idea. You know the background from where comes or occurs G, F and C. What is their nature? Now you are in a position mathematically, conceptually, with clarity, apply these concepts to find center and radius. Center and radius, they are mostly negative G, negative F coordinates of center, and radius is given by G square plus F square minus C. After completion of first proof, let's move to second proof. Question number next. Prove that x is equal to a cos alpha and y is equal to a sin alpha, representing a circle having center at origin, representing a circle having center at origin, and radius is equal to a. We have given equations x is equal to a cos alpha and y is equal to a sin alpha. X is equal to a cos alpha and y is equal to a sin alpha. From polar coordinates, that is the way to transform polar coordinates to rectangular and vice versa, and rectangular to polar. X is equal to a cos alpha, y is equal to a sin alpha. These are known as parametric equations of circle. Parametric equations of circle. Parametric equations of circle, or one can say polar coordinates, transformation of from polar coordinates to rectangular in two dimension. We are familiar from the basic formula of trigonometry from Pythagoras theorem. That is a wonderful beginning of the trigonometry. It states that sin square alpha plus cos square alpha, its tantamount to 1. From these two equations, manage sin alpha and cos alpha, plug in the values, then you are in a position to find center and radius, and also proving that these two equations collectively represents a circle having center at origin and radius is equal to a. From this, cos alpha is given by, shift a here, it will become x over a. Similarly, sin alpha is given by y over a. Plug in here values. Sin alpha means y over a whole square, x over a whole square is equal to 1. We are in a position to distribute this power to both y and a because there is no middle symbol, positive or negative whatsoever. It can be written as y square over a square plus x square over a square is equal to 1. Our denominators are homogeneous, they are identical. In both fractions, a square is the denominator. Denominators are homogeneous. Write denominator one time. No transition in the numerators. Y square plus x square is equal to 1. From this, a square from division to multiplication from left to right, and I can sort them out as x square first, y square later is equal to a square. Y square is equal to x square. These two equations can be written as, in order to compare with the standard form, they can be written as x minus 0 whole square, y minus 0 whole square is equal to a square. So these are the coordinates of center. Center is at origin, and this is value of r square is equal to a square. From this one can infer that r is equal to a. We have given x is equal to a cos alpha, y is equal to a sin alpha. If you are good at mathematics or in physics, you have already seen these two equations as parametric equations of circle, or from polar coordinates to rectangular, rectangular to polar, but in two dimensions. Look at these two letters. If these two letters are identical, then it represents a circle. If they are different, then it represents ellipse. Then it represents an ellipse. Moving towards next question. Moving towards next question. The coordinates of the center and the radius of the circle from this given equation. We have given an equation that is x square plus y square plus 2 times q times cos theta times x plus 2q sin theta times y plus q square is equal to 0. We are asked to find its center and radius. Its center and radius. We compare this with general equation of the circle, that is x square plus y square plus 2gx plus 2fy plus c. In order to find center and radius, we take the help or assistance of general equation of circle. It has center at negative g and negative, these are the coordinates of x and y, and while radius is given by g square plus f square minus c. So after making coefficient of x square y square 1, we have to compare. Luckily, already coefficient of x square y square is 1. Already coefficient of x square is y and y square is 1. Just compare x power 1 term with x power 1. We have 2g is equal to 2 times q times cos theta. 2 to cancel out, g is equal to q cos theta. Similarly, comparing the coefficients of y power 1, we have 2f is equal to 2q sin theta. 2 has been neutralized. F is equal to q sin theta. While the constant term, that is q square, it is the value of c. Its value of c. Okay, plug in the values. G and F here, it's our center. For radius, we have to plug in the values of G, F and C in that equation. So we have center of our circle is negative G, negative F. So we have managed the value of G as q cos theta, negative q cos theta, in that case negative q sin theta. That's our center. That's our center. What about radius? Radius is given by root g square. G means q square cos square. G square. G means q square cos square plus f square. F square means q square sin square. Q square sin square. Negative value of c is q square. Value of c is q is square. We have r equal to taking q square common, we have cos square theta plus sin square theta negative q square. As we know that value of sin square plus cos square is equal to 1. Value of cos square plus sin square is equal to 1. So we are left with q square and minus q square. We are left with q square minus q square. Let me write this step again. R is equal to q square common. We have cos square plus sin square negative q square. Cos square sin square is equal to 1. Cos square sin square is equal to q square times 1 negative q square. So q square minus q square. So our r is equal to 0. R is equal to 0. So this circle turns to be merely a point. Merely a point. A point having coordinates negative q cos theta and negative q sin theta and radius is equal to 0. It's merely a point. It's merely a point at negative q cos theta, negative q sin theta. Our circle turns to be a point circle. A point circle having no area. Having no area. In that case, the right option is to be B. Negative q cos theta, negative q sin theta, the coordinates of center, and radius is equal to 0. Whenever you are asked to find center and radius, just keep these two things in mind. This is general equation of circle. It has center at negative g negative f, we have proved, and r is given by g square plus f square minus. Just manage the value of GFC. GFC. What is g? What is g? 2 times g is the coefficient of x. Compare the coefficient of x with x and coefficient of y with y. Don't forget that coefficients of x square y square must be 1. Coefficient of x square y square must be 1. Then our story, then our love story, then our saga starts. If the coefficient of x square y square is not 1 and you are starting your love story, then it's your fault, blunder. First make the coefficient of x square y square 1, then look for the value of g, f and c. You are going to work wonder in case of circle. Moving towards question number next. Moving towards next question. If x, 3 and 3, 5 are the end points of diameter of a circle. If x, 3 and 3, 5 are the end points of a diameter of a circle and center is at 2, 1, then the value of x and y. We have given a circle whose end points of diameter are given there are x, 3 and 3, 5. While center is at 2, 1. 2, 1. Find value of x. Find x as well as y. Find x as well as y. We know that if name them, it's A, it's R, B. These are the end points of diameter. We know that. From any point on the circumference to the center is known as radius. Any point from circumference to the center, its distance is known as radius, as well as this is also radius, as well as this is also radius, as well as this is also radius. We know that. All these are radii. We have given two end points of the diameter of the circle. These are the 2 end points of diameter of the circle. 3, 5, 2. And center lies at the mid of both these A and B. Our center lies, say suppose C, is at the mid of AB. Central value of AB. Center of AB. Midpoint of AB. Exactly midpoint of AB is our center. Utilizing that concept, applying midpoint formula, this is our x1, y1, and these are x2, y2. It doesn't bother you if it is x2, y2 and it is x1, y1. Dividing point, central point, midpoint, it must be denoted by xy. And our midpoint formula states that x is equal to x1 plus x2, mean of x1 and x2. Similarly, y is mean of y1 and y2. Mean, average are simply x1 plus x2 divided by 2, y1 plus y2 upon 2. This is our x1, y1, this is our x2, y2, this is our xy. Plug in the values. Here, x, this is x is our 2, and x1 is our x, plus x2, that is 3, divided by 2. Move this 2 here. 2 times 2 is equal to x plus 3. 2 to the 4, shift 3 here, negative 3, and so x is equal to 1. Similarly, our y, in that case, y is what? Y is equal to y1, 3 plus 5. 3 plus 5 divided by 2. Sum of 3 and 5 is 8. 8 divided by 2, that's our 4. So, the value of x is 1. Value of x is 1 and value of y is 4. And value of y is 4. Value of x is 1, value of y is 4. They have written this in coordinate form or in pair, but I don't because x lies as the end point of the diameter and y is the coordinate of the center. They cannot be written together as an ordered pair as they have given or as they have demanded. It is not the case. This misprinting or error has been taken from Kip's book as it is. They have written the answer. I have kept everything simple and original, but but x belongs to another different ordered pair and y belongs to different ordered pair. That's why I have written the answer in that form. Mine x is 1, y is 4, or one can write value of x, y in curly bracket. It's equal to 1. It's equal to 1. But it is more appropriate. X is equal to 1 and y is equal to 4. Moving towards final question of the frame. Yes. Moving towards next question and final question. A wonderful question overlapping the ECAT and BCAT. To me, it's overlapping ECAT and BCAT. It reads as a square is inscribed in the circle. We have a circle. A square has been inscribed in this. A square has been inscribed in this. I beg your pardon if my square seems to be a rectangle. This is a square. This is a square. A square is inscribed in a circle of radius r. Of radius r. We have this is equal to radius r. This is also radius r. This is radius r. Then what is the length of its side? A square has been inscribed in a circle. A square has been inscribed in a circle. In a circle. Such type of circle is called circumcircle. Circumcircle because it is a figure containing another figure. Circumcircle, a figure containing another figure. Usually it's a circle. If it contains another figure inside, then its name will be circum. And here inside there is a square. We call it in square because it lies inside another figure. So this circle is circumcircle and this squares are inscribed something inside another figure inscribed. Okay, now we are asked to find the length of this square, the length of this square, the length of this square, the length of this square. If I draw the diagonal, look at this. These are diagonal of the square. Diagonal of a square is equal to diameter. Diagonal of the square. Diagonal of the square is our diameter. If we take a square, if we read the square, it is known as diagonal. If we check same line, as it is passing through the center, this is a chord passing through center. It is a chord passing through center. It's our diameter. Both are equal in that case. Diagonal is equal to diameter. If I take that portion only, this is our diameter. That's equal to 2r. If I name them, it's A, it's also A, because these are the sides of a square. Suppose they are equal to A. We are in a position to apply Pythagoras theorem. It's our hypotenuse. From triangle point of view, it's our hypotenuse. It's our base and it's our perpendicular. Look at the line. From triangle point of view, it is hypotenuse. From square point of view, it's diagonal. From circle point of view, it's a diameter. Wonderful intersection of three figures. Wonderful overlapping of three figures. Apply Pythagoras theorem here. Hypotenuse square is equal to base square plus perpendicular square. Here, hypotenuse is r 2r square. Base is a square as well as perpendicular. Perpendicular is also a. So this is 4r square is equal to 2a square. Applying table of 2, we have a square is equal to 2r. A square is equal to 2r. We are interested in a. We have a square is equal to 2r square. Taking square root, we have root 2r. If we take square root of on both sides, a square is a perfect quantity a, r square is a perfect quantity r. Root 2 remains root 2. This is the length of the side of the square. This is the length of the side of the square. It's equal to root 2 times radius. Root 2 times radius. Root 2 times radius. And we are asked to do so. And we are asked to do so. In that case, our option is B is the right option. One should have clear concept. Look at this figure. Look at this question. This is diameter from circle point of view. Same line, it's diagonal of the square. Same line from triangle point of view, it's a hypotenuse. It's hypotenuse. Okay. See you in next frame for conic section or NTSPIV question. It's all by itself next.